friends. In this session, we will study about the measure of dispersion. In measure of dispersion, we will study interquartile range and quartile deviation. In previous session, we have seen that we have discussed the range as the measure of dispersion has certain limitations. It is based on two extreme items and it first to take account of the scatter within the range. From this, there is reason to believe that if the dispersion of the extreme item is discarded, the limited range thus established might be more instructive. For this purpose, there has been developed a measure called the interquartile range. The range which includes the middle 50% of the distribution. That is, one quarter of the observations at the lower end, another quarter of the observation at the upper end of the distribution are excluded in computing the interquartile range. In other words, interquartile range is the difference between the third quartile and the first quartile. As you see here, it is the absolute measure. If we see, the interquartile range is third quartile minus first quartile, the Q3 minus Q1, where the Q1 is the first quartile, Q3 is the third quartile. If you have to take the relative measure for this, the coefficient of interquartile range, which would be Q3 minus Q1 over Q3 plus Q1. So this we have taken. Very often the interquartile range is reduced to a form of the semi-interquartile range, or which is also called quartile deviation, by dividing it by 2. If we interquartile range divide by 2, we get the quartile deviation. Interquartile range divided by 2. Look at this. For this, the absolute measure is quartile deviation is equal to Q3 minus Q1 over 2. And the relative measure would be same as for the interquartile range. The coefficient of quartile deviation is equal to Q3 minus Q1 over Q3 plus Q1. Quartile deviation gives the average amount by which the two quartiles differ from the median. And in a symmetrical distribution to the above quartiles, Q1 and Q3 are equidistant from the median. You see, here I draw a line, explain this first. This is our data. And here I put some points, this is our median, and this is our first quartile, this is our third quartile. Look at this. So here you see this one is median. We have this is median, and this is the first quartile, this is the Q1, and this is the Q3. So we are taking this in account, in our account, Q3 minus Q1. This data we are getting the interquartile range. We are excluding 25% on the above side of Q1 and 25% on the downside of Q3. So here you see the deviation from median would be same of Q1 and Q3. This deviation would be same. So the asymmetrical distribution of the two quartiles Q1 and Q3 are equidistant from the median, which I have already explained now. So median minus Q1 is equal to median minus Q3 minus median. And as such, the difference can be taken as a measure of dispersion. The median plus minus quartile deviation. Median plus minus quartile deviation covers exactly 50% of the observation. In reality, however, one solution finds a series in business and economic data that is perfectly symmetrical. Nearly all distributions of social series are asymmetrical. In a symmetrical distribution, Q1 and Q3 are not equidistant from the median. As a result, a symmetrical distribution includes only approximately 50% of observations. So when quartile deviation is very small, it describes high uniformity or small variations of the central 50% items, and the high quartile deviation means that variation among the central items is large. As we know that the deviation, the quartile interquartile range, the quartile deviation, which would be low, it would be better for us. The quartile deviation is absolute measure of dispersion. The relative measure, we know that it is the quartile deviation is the absolute measure, and the relative measure I have explained, the coefficient of quartile deviation we could get in this way. So these are the position measure of dispersion we have seen. Now we take some examples. Computation of quartile deviation, interquartile range, we see how we get this. So we have an individual observation. We see here the marks obtained by the students out of 50 is the 20, 28, 40, 12, 30, 15 and 50. So we have to find out the first interquartile range, then the computation of interquartile or computation of the quartile deviation. We see how we get this one. So the marks obtained, first we arrange in the quartile or the decile, the percentile, the median. First of all, you have to arrange the data in ascending or descending order. So first we arrange this data in ascending order. So I write the data in ascending order here. Just a moment. I write this data here. This the smallest data is here you see, which is 12. Number second is 15. Number third is 20. Number 4 is 28. Number 5 is 30. Number 6 is 40, and number 7 is 50. So we arrange in this way. The data X we will put here. So 12, the first data. Second data is 15. We have. Third data is we have 20, then 28, then 30, 40 and 50. So we see here we take the number, the cumulative frequency, because the every data is only once here in the individual observation or the raw data. So we get here 1, 12 is one time, 15 is the second number data, 1 plus 1 is 2, it is 3 and 4 and 5 and 6 and finally 7. So we have got this, the n is equal to 7, we have the 7 data now. So now we will find out how we get these all. The first quartile and the third quartile we have to find out first. So you see here the formula for these individual observations for quartile calculation. For the Q1, the value of n plus 1 by 4th item, and the Q3 is the value of 3 into n plus 1 by 4th item. So first we find out the Q1. Q1, we get value of n plus 1 by 4th item. So n is 7 here, you see, n plus 1 by 4th item. So we get here value of 8 by 4th item. So we get here value of second item. So the value of second item is 15 here. So we write here 15 means 15. So we write here 15. So we have got Q1 15. Now we have to find out the Q3. For Q3 is the value of 3 n plus 1 by 4. So 3 n plus 1 by 4. So 7 plus 1 by 4 we already know it is 2. So I am putting directly here 2 item. So we get here value of 6th item. So let us see, the value of 6th item is 40. So Q3 is 40 here. We have got Q3 40. Now if we have to find out the quartile deviation, we know that the quartile deviation, I explain you again, I show you the formula for quartile deviation, Q3 minus Q1 over 2. So look at this, Q3 minus Q1 over 2. So we put these values here in quartile deviation. We get Q3 is we have 40 and Q1 is 15 we have, divided by 2, so it is 25 over 2. So which would be equal to 12.5 would be the quartile deviation for this data. Or we could get some other things also. If you need the coefficient of quartile deviation, that is also very simple. Quartile deviation, you have to find out the coefficient of quartile deviation as I explained you earlier. You could put in this formula and you get the coefficient of quartile deviation through this Q3 minus Q1 upon Q3 plus Q1. So it is also very simple. I explain you here coefficient of quartile deviation is Q3 minus Q1 over Q3 plus Q1. So you just put the value here. We get the values I explained here. So we get the values Q3 is we have 40 minus 15 over 40 plus 15, so which is 25 over 55. So we get here 0.455. So this is the coefficient of quartile deviation. In this way we could easily find out the range also. If you have to find out the range would be the 25 here, because Q3 minus Q1 is the range of interquartile range of this distribution. So in this way we could easily find out the range, interquartile range, quartile deviation, everything. So now we see how to get the quartile deviation, interquartile range, coefficients of quartile deviation of discrete series in ungrouped data. So look at this example. There is a marks obtained by the student is given to us 10, 20, 30, 40, 50 and 60, and the number of students, their frequency is also given 4, 7, 15, 8, 7, 2. Now, so it is already in ascending order. You look at this, the x is in ascending order. So just we have to compute the cumulative frequency here first. So we get the cumulative frequency here. Now we compute the cumulative frequency here. It is 4 plus 7, 11. 11 plus 15 is 26. What we are doing? We are just adding this, here we add 8, 26 plus 8 is 34, 34 plus 7, 41, 41 plus 2, 43. So we have got 43, which is n. And we have now here 43, the sum of all the frequencies n. So we have to find out the Q1 and Q3 in this data. The same thing here. For first of all, you have to find out the Q1. So Q1 is equal to value of n plus 1 by 4th term. So we get here the value of n is 43 plus 1 by 4th term. So it is 44 over 4, which would be 11 now. So we get here a value of 11 term. That is Q1. So the value of 11 term, you see the value of 11 term, 11 is here, the value of this term is 20. So we get here 20. So Q1 we have got 20 here. And now we find out Q3. Q3 is the value of 3 n plus 1 over 4 term. So look at this, the value of 3 into n plus 1 over 4, we know that it is 11 already, there we have calculated earlier. So we get here value of 33rd term. Look at here cumulative frequency column, there is no 33 is there. So 33 will comes under 34 because it is greater than 26 and less than 34. So we get the value of under 34, we see the value is 40. So Q3 we have 40 here. Now we have Q3 and Q1 both. If you have to find out the interquartile range, first we find out the interquartile range. Interquartile range is equal to Q3 minus Q1. So look at this, Q3 is 40 and Q1 we have seen there calculated 20, which is 20. We get here interquartile range is 20, but semi-interquartile range or the quartile deviation which is Q3 minus Q1 over 2. So Q3 minus Q1 we have already 20 and it is divided by 2, so we get 10. Now we see the coefficient of quartile deviation. We know it is equal to Q3 minus Q1 over Q3 plus Q1. You know that Q3 minus Q1 is 10, it is 20, or I write the complete here, okay, sure. So it is 40 minus 20 over 40 plus 20. So we get here 20 over 60, so it is near about 0.333. So this we have coefficient of quartile deviation for ungroup data. So in this way you could easily find out the interquartile range, quartile deviation, coefficient of quartile deviation. It's very easy in ungroup data and the raw data. Now we see an example of non-continuous series of group data. It could be applied for the continuous non-continuous series. I have taken an example of non-continuous series where open-ended data are there. Here you see the wages in rupees per week is given in the class interval form. It is less than 35, 35 to 37, 38 to 40, 41 to 43 and over 43 is given to us. And the number of workers, the frequency is also given to us, the 14, 62, 99, 18 and 7. So here you see how we solve the steps and the formula for this, getting the quartile deviation, the first quartile and third quartile. So the steps for this. The step 1, find the quartile classes. First of all, we have to find out the quartile classes. Just a moment. Quartile classes. So the Qn is equal to a small n into capital N over 4. The small n is the quartile, first quartile, second quartile, third quartile. The quartile number is there, 1 and 3rd. We would put instead of n. So here, and the capital N is the sum of all frequency. Okay, so this is the quartile class we have to find out first. And the second thing what we have to do, the step 2 is quartile value. The quartile value, how we'll find out? The quartile value is the Qn, the first quartile or the third quartile, Qn, n is the number of quartile here. So L1 plus Qn minus Cf, the cumulative Cf is the cumulative frequency over the frequency, and L2 minus L1. So here in this formula, if you put these values, we could get the quartile value. So first of all, we simplify, we compute the cumulative frequency here. So We start with cumulative frequency. I put down here, it is 14 plus 62, 76 plus 99 is 175. 175 plus 18, it is 193, and 193 plus 7, we get here 200 now. So it is our n, we have capital N. Now we find out the quartile class Q1. For Q1 we see Q1, here you see in this formula Q1 n is 1 here, and capital N is 200 over 4. So it is 200 over 4, which is 50. So we have got here 50 Q1, and here we also find out Q3. So Q3 is n is 3 here, small n. Capital N is again 200 by 4. So it is 150 now. Now we have to find out the Q1 quartile. First quartile we get here. For Q1 we have the formula L1 and this all. So we have to get here, I put down first formula L1 plus Q1 minus CF over F into L2 minus L1. This is for this, and for Q3 it is L1 plus Q3 minus CF over F L2 minus L1. This is our formula for Q1 and Q3. So here we see the quartile class is 50, the quartile class value is 50 here. So 50 will come in 76, under 76, so the quartile class, this would be the quartile class for first quartile. And this is 150. So 150 will come under 175. So this is the second quartile class we have. Okay. So we see here, this one is L1 for first quartile, 35 is L1, this one is L2, this one is F, and the cumulative frequency CF is cumulative frequency preceding class of quartile class. So this would be CF for this first quartile. So I put these values here in first quartile formula. It is Q1 L1, you see here lower limit is 35. We put here 35. Q1 we know that it is 50, we have calculated it. CF, the cumulative frequency preceding class of the quartile class, is 14. We put down here 14. Here the frequency of quartile class is 62. We have to put here 62. And L2 minus L1, so look at this here, L2 is 37 and L1 is 35. Now we simplify this. So Q1 is equal to 35 plus 36 over 62 into 2. So Q1 is equal to 35 plus 1.16. If we simplify these, we get here 1.16. So Q1 is 36.16. This is the first quartile we have got here. Now look at for third quartile. So the quartile class value is 150 for third quartile, which comes here. So we put here, this one is our L1, this one is our L2, this is our F here, and this is our CF for this third quartile. The cumulative frequency always preceding class frequency is called the cumulative frequency we have to take here. So for Q3, if we put these values to get Q3, L1 is 38 here, Q3 is 150, cumulative frequency, look at cumulative frequency 76, and the frequency of this class is 99, L2 is 40 minus 38. So now we simplify this. So Q3 is equal to 38 plus 10 minus 6 is 4 and 14 minus 7 is 7 over 99 into 2. Further we simplify. So we get here, now we get here 38 plus 1.49. if we simplify this, so we get 39.49. so this is our value of third quartile. So we have got the first and third quartile. Now we find out interquartile range. Interquartile range. Interquartile range is Q3 minus Q1. The same formula we have to apply here. The Q3 we know that 39.49 and Q1 is 36.16. So we get here interquartile range is 3.33. Now we find out quartile deviation. Quartile deviation is Q3 minus Q1 over 2, so which is 3.33 over 2. So we get here 1.67. Now coefficient of quartile deviation over the interquartile range would be same. So we find out coefficient of quartile deviation. So we get here, we have the formula Q3 minus Q1 over Q3 plus Q1. We put these values here, 39.49 minus 36.16 over 39.49 plus 36.16. So we get here 3.33 in numerator, and denominator if we add this 75.65. So we have got here 0.044 is the relative measure of quartile deviation. So the relative measure of dispersion, coefficient of quartile deviation. So this is a way to find out the group data, find out the quartile deviation, interquartile range, coefficient of interquartile range, coefficient of quartile deviation. So it's very easy to calculate Now we see some merits and limitations of this interquartile range and their measure of dispersion. We see the merits here. First, the special utility in measuring variation in case of open-ended distributions or in one in which the data may be ranked but measured quantitatively. So open-ended data we have taken in the ungrouped data less than 30 and more than, so it is this sort of data we could easily find out through this quartile deviation, because these are the open-ended data. And the second thing is useful in erratic or badly skewed distributions, because it does not affect the presence of extreme values, because the extreme values whatever may be, it does not affect. We take only 50% of the data in between, the 25% upper and the lower we exclude, so it does not affect there. So these are the merits. And the limitations we see, it is not capable of mathematical manipulation. It is not capable because it does not include all the values. Its value is very much affected by sampling fluctuation. If we fluctuate the sampling, it very much affect that thing. So because the number of data, if we increase or decrease, it will affect. The other limitation is it ignores 50% items. We know already the first 25%, last 25%. It really does not show the scatter around an average, but rather a distance on a scale, because it is a position measure. So these are the limitations of interquartile range, quartile deviation. So it was a session for regarding the dispersion in interquartile range and the quartile deviation. Thank you very much for this attending this.